Hello and welcome to this repair tutorial, and today we're going to look at a Marantz and the model number is PM7000. In terms of general specifications, power output in class AB mode is 95 watts per channel RMS, and that's 2 times 8 ohm speakers, and the amplifier also supports dual speaker systems. So from the front fascia you can select between system 1 and system 2 or both, or if you're connecting via the 1/4 inch jack socket headphones for private listening, then you can just disable both speaker sets. You can also bypass the tone control circuits if you wish by selecting source direct mode, and then frequency response is 10 Hz to 50 kHz, and total harmonic distortion comes in at 0.03%, and input sensitivity, because you can connect the turntable directly with a moving magnet type cartridge, is 2.5 millivolts, and then all of your other line inputs come in at 150 millivolts. Dimensions 440 by 159 by 370, and the weight of the amplifier is 12.3 kilograms. At the time of sale, it also was supplied with a remote control, and you have a motorized volume control potentiometer. Now, what I want to sort of show you next is really the rear of the amplifier. And there's a number of things that I want to sort of point out to you on this amp. If you look on the left hand side where you see the RCA sockets, I've just put a circle around, and that's where it says processor. Now normally the amplifier should be provided with 2 links. So you'll need to remove these if you're going to of course take off the back panel. But the importance there is if you don't do that, then you probably have the low audio situation. So just make sure that those links are in, because it gives you the ability, if you wish, to connect to a secondary preamplifier if you wanted to, if you're not using those links. The other thing that I want to sort of highlight, and I've done this via the arrow, is that when you disassemble the amplifier, it uses a common ground connection throughout. So what happens here is you'll not see any painted surface over those screw holes, and that's done deliberately. So if you're going to repair the amplifier, before you put it into test mode, you just need to put the back panel on, put the screws into the rear speaker terminals where you have the common ground point, and then also connect a number of the screws so you're just securing the back panel then to the chassis. Very, very important that you do that. And then on this amplifier being the 7000, you can see on the right hand side, just below the power input, normally what you have there are sockets where you could connect additional equipment to be powered from the amplifier. For the 7000 you don't have that. Now, what was the issue with this amplifier when it arrived in the workshop? Well, it is the most common issue that you have, and it's related to the age of the amplifier. So typically what you'll find is that either you'll have intermittent audio, and that could be one or both channels, or you may have some degree of distortion, or maybe a differential between the 2 channels. And it's a very, very common issue. And what you have to do is you have to, of course, remove the back panel. And then what you're going to do is you're going to disassemble the amplifier, and you're going to look at each one of the circuit boards. And often I use a term called reflowing. All I simply mean there is that you need to inspect each of the solder joints on the boards, and you need to re-solder them. Because what you will find is that there will be multiple dry joints on every single board. So here what you can see is once the back panel has been removed, we're now focusing on the input selection board. Now with the 7000 series, it uses these red relays, as you can see. So these will select all of the different inputs. And then what you also have is a secondary board. And then what you need to do is, and in terms of disassemble, it's very easy. What you have is just a PCB pillar where you see the flex cable coming in. You just need to release that. And then what you'll see is that there is a 3-pin cable which connects then into the volume control and preamplifier stages. And then if we turn the board over, because it just unclips from the locating slot, which you can just see in this slide, what I've done here is I've put a series of circles around specific areas that you need to concentrate on. Now I always mention this is about the RCA input sockets, and because they're mechanical stress points, the amount of solder used during manufacture really was quite minimal. So what you'll find is that there will be cracks around each one of these, and then also as well where that other board plugs in, that's towards the centre up towards the top. You'll find again dry joints on all of those pins. Just to reiterate, you need to inspect all of the solder joints, and if you see any form of discoloration or cracking, you need to resolder. So here what I've done is I've took that secondary board, and you can lift it up off the PCB pillar, and again I'm highlighting here that you will have dry solder joints on all of those connections, and then also on the multi-pin connector where it connects then to the main input selection board. Once you've done that, the next area of focus then, because all I'm doing is I'm just working from left to right, looking from the rear of the amplifier, is now to look at the main power amplifier stage. And the amplifier is nice to work on. It's very modular. So it enables you to remove the power amplifier stage, put the rest of the amplifier to one side, carry out the work, and then of course when you reassemble, it's just 4 screws and you slot it into place just to lock it into position then. Now what you can see from this amplifier is that at some point in time it's been stored maybe in a damp environment. It could be just a level of moisture, but what I'm looking at on here is that when I look from the top, you have these RF screen cans around the input stages for the left and the right channel, and what you can see is that there's some moisture damage which is on the top, and you could also smell that there is quite a sort of damp smell to the amp. And what you'll find also is that the dust which is settled tends to be a little bit sticky. So throughout this service and repair, all of that was removed just to get it back to how it should be. When we look here, because the module is removed, I've just took a shot from the back, so you can see now just disconnected the main power supply from the power output stage, and then also the multi-pin cable which goes off towards the headphone socket, and then you also have the connection which comes via the preamplifier stroke volume control board. And then what I'm focusing on next is really to look at that power amplifier module. So it's very, very easy to work on. Now what you'll find here is that there will be multiple dry joints. So on this photograph, I've just drawn the circle around a number of points or a number of components. So highlighting again that there was some form of moisture over time, which of course has had an impact onto these metal screening cans. And then towards the rear of the amplifier, I've drawn a yellow circle, and these are the speaker protection relays for system 1 and system 2. Now the specification for these is 24 volts DC coil, and they are double pole changeover relays, so readily available and no difficulty to source them. You could attempt to remove the top cover of the relays and try and clean them, but again, this amplifier is maybe 30 plus years old, so that's a lot of operation, and if it's been run at quite high power, then of course those contacts would be oxidised and would lead then to some level of distortion or maybe intermittent loss of sound. A common issue that maybe the user can describe is that a low volume get distortion, and then as they increase it, maybe it goes away, and that's just the current which is flowing through the oxidised contacts, just overcoming some degree of resistance. And then what I do here is I'm just spinning the amplifier module over. And what I'm doing is I'm focusing now on all of the dry solder joints, and they will be extensive. So I've just drawn a series of circles around different components. The ones that you're seeing here are different power transistors and pre-driver transistors. So really take the time to inspect every single solder joint, as I said earlier, in the same way you did for the input selection board. Don't rush the work, and also as well, once you've reflowed or resoldered all of the solder joints, the important thing is to always verify and check your work. It's very easy to maybe have a solder bridge where when you are resoldering component leads, some of them are very close together and you may accidentally solder the two connections together. So you just need to verify that that is not the case. And then here what I show you is the 2 speaker protection relays which have been removed. So as I said earlier, you can see the specification being a 24 volt coil, and these are double pole changeover relays. And what I install are high quality relays which just provides the longevity. On this photograph here, this is the protection board. Now it's very important to remove that board and turn it over, and you will definitely find dry solder joints on the pins of the protection IC and also some of the resistors as well as the multi-pin socket where it plugs into the power amplifier module. So again, you must reflow all of those connections. And then here we have a close-up shot. So this is the EI power transformer, and it has multiple windings. From my own experience, and I've worked on a lot of these Marantz amplifiers, I've never come across one yet where you have, for example, loose laminates, which can happen on any EI type transformer over time, and you get this excess 50 Hz or 60 Hz frequency hum coming from the transformer. So that tells you, it is a good quality transformer. And then you can also see as well, there's a copper band around it which also acts to provide additional screening. And then here, what you're looking at is the power supply board, and it's quite substantial. What I've done is I've drawn a number of circles. So the circle which is yellow, that is the startup relay, and then the smaller transformer, that forms part of the startup circuit. So the AC comes in and then it goes via the mechanical switch from the front, and then it will then provide power directly to the startup transformer, which is rectified, smoothed, regulated, and then that goes off then to the microprocessor. So during power up, the startup circuit operates, and providing that there's no fault condition, what will happen is that the power then will be energized to the startup relay, and in turn that will provide the primary voltage to the large power transformer, and then the amplifier will complete its power up. You can also see as well the two large canisters with silver top. Those are the large electrolytic smoothing capacitors, and then just in front of there is the bridge rectifier to convert the AC to unsmoothed DC, and that's mounted onto a small heatsink. Now when you turn the board over, and what I've done here is I've just supported it just by a can, and this is one of the cans which is used just to remove all of the dust, so it's just a compressed air line. And I've again put a number of circles around specific areas that you need to concentrate on. So typically it's the connections on the rear, and then also around the transformer, also the large electrolytic capacitors, and then the interconnecting cables. So take your time again, just be aware that if you've maybe powered up the amplifier, the large electrolytics may still hold a charge, so you may want to just check them to make sure there's no DC voltage across the pins. And if there is, then absolutely don't short them out with a pair of pliers. What you need to do there is just to discharge them, and you can buy a capacitor discharge tool, relatively low cost, or you can make yourself one yourself just by using a resistor and then interconnecting cable, then just to control the dissipation of the energy within the smoothing capacitor. And then here where I'm focusing on, this small circuit board here has the headphone jack socket on it. That's the thing that you can see to the right hand side, and there is a locking screw in place just with a large washer. And those two selection switches are used to select between system 1 and system 2 for the speakers, and you can see the multi-core cable which plugs in. Now when you remove that, what you'll find is that there will be multiple dry solder joints on there, and I'll show you that in a second. Before you do that, what you need to also do is to clean the switch contacts and then also the headphone jack socket. So in my case I use De-Oxit, and I will spray it directly into the headphone jack socket, and then I will connect a set of headphones and then plug the 1/4 inch jack in and out multiple times. And then when you look at the switches, you'll see that there's small access holes from the top, and you can squirt the contact cleaner directly in, leave it for a few minutes just so it gets to work, and then just operate those switches multiple times, and you'll find that they'll come back and you'll have no issue with sort of intermittent operation. And then here you see the circuit board lifted up, and again from manufacture what you'll find is on those selection switches there's really a minimal amount of solder which has been used, and the same for the head jack or the headphone jack socket. So again, just re-solder them and then also check all of the other connections. And then here what you can see is two circuit boards. The first one, which is the flat board, this here is the tone control circuit, and then the one which is vertically mounted, and you can sort of just make it out, that is the volume control board. And then what you need to do is to release the fixing screws on the top, and what you'll find is there's two screws with some ground connections on the left and then on the right, and then you have three fixing screws if you look down, which secures the front bezel to the main chassis. And then here what I've done is I've just taken a side view, and you can see the selection switch, and then this is tone defeat, and then you can also see the different potentiometers. This board is dirty because it's not yet been cleaned, but later on you'll see that it has been cleaned. And the areas that I'm focusing on here, of course, is I'm going to clean the switch up, and then I'm also then going to focus onto the solder side of the board. And again, it's the multi-pin connectors that you need to focus on. On the left hand side there's two circles. What you'll find there are the voltage regulators, and because they run reasonably hot, and again minimum amount of solder, you'll often find dry solder joints around there, so re-solder. And then also on the tone defeat switch, also on the balance, bass and treble control potentiometers. Anywhere there's mechanical stress, lacking of solder, or age-related breakdown of solder, you need to re-solder all of the connections. So what I've done here is I've just taken a zoom in view of one of those multi-pin connectors, and you can already see probably on most of those pins that there are cracks around all of those joints. So you can imagine an electrical signal trying to bridge that connection, and sometimes that connection is lost or it's intermittent. So carry out the work. And then here what we're doing is we're just taking a top shot of the volume control, and you can see that it is a motorized volume potentiometer. And again, while the board is out, you need to squirt directly then into the volume control potentiometer with De-Oxit. Leave it for a few minutes and then rotate the potentiometer backwards and forwards, fully clockwise, fully anti-clockwise. You tend to find with potentiometers the oxidization often is at the extreme ends, so just make sure that you go full travel on that to clean off any oxidization. And then once that has then been done, and you can see here what I've done is I've just reassembled the amplifier, and you can see also as well that the back panel has also been put back in place. The brand new relays are there, and then we then come to the point where we need to do the test phase and then also the alignment. And again, with this amplifier, it is a joy to work on. It's not something which is very difficult in terms of really, there's some amplifier brands where you just wind up with so many nuts, bolts, screws to disassemble. And then when you do any test or sort of any fault finding or alignment, it's just difficult. You don't really have that good access, and you're kind of thinking, maybe from a design point of view, it could have been improved, but not for the Marantz. Really, really nice design and also really, really good sound. So what you have on the 7000 series, because it doesn't operate in Class A mode, you only have really two adjustments or alignments that you have to make. The first one is to check the DC offset, and then the other one then is to adjust the output bias. So what I show you here is the adjustment then for the DC offset. And again, very, very easy to do. So what I've done is I've taken an extract from the service manual, and this is the left channel as you see. And what you do is remember to select System 1 or System 2, depending which speakers terminals you're connecting your multimeter to. And you just set your multimeter to millivolts, put your meter probes or lock them into position onto the speaker terminals. Leave the amplifier normally running for about 30 minutes. And then what you're looking to do is to adjust then to as close to 0 millivolts as you possibly can, but you have a tolerance. So as long as it's within plus to minus 10 millivolts, then the alignment is correct. Now remember, when you do this alignment, you shouldn't have any inputs connected at all. Your volume control should be at minimum, and then your bass, treble and balance controls should all be at midpoint, and of course you wouldn't have any headphones connected. And then once you've made that adjustment, you need to do that also then for the right channel as well. Now when we come to the alignment then for the bias for each channel, what you can see here, and I've highlighted, these are what we call the emitter resistors. Now the service manual doesn't show exactly the same type of emitter resistors that you see here. The service manual shows that the leads for the emitter resistors protrude from the top, but they don't. So what you have to do is you have to connect, and most importantly, don't just use your multimeter probe leads, put some hook clips on there. You need to connect around the pins of the emitter resistors. Now these emitter resistors are what we call dual package type. So that means that when you are connecting your multimeter, you need to go to the outer pins, not with reference to the center pins. And then once you do that, it's again a straightforward task then to perform your alignment. So here we look back to the service schematic and an extract, and what you can see here that we are looking to adjust the bias until we have a reading of 18 millivolts, and you are going to measure across the emitter resistor. And as I mentioned before in other tutorials, often these amplifiers have never had any form of service work done or any kind of alignment. So they're literally as it left the factory, and what you could find is that the preset potentiometers are maybe dirty. And then if you try and make an adjustment, it's twitchy or it's coarse or it just sort of doesn't kind of feel right, and it's more difficult to align. If that is the case, nothing wrong with turning off the amplifier, spraying a small amount of contact cleaner or De-Oxit onto the preset potentiometer, and then just rotate it backwards and forwards a number of times, and you're just going to clean that carbon track. Then put it back to roughly the position that it was previously, power up the amplifier, and then of course you can make your adjustment. And what you'll find is that the adjustment that you make here, because these preset potentiometers are not multi-turn like 10-turn, they're single track, it's just going to take you a little bit of time. Just make a small adjustment, then wait, and then what you'll find is the millivoltage then will increase or decrease depending on direction, and then it will then start to stabilize, and then you can then repeat the adjustment until it's approximately 18 millivolts. And once you do that for the left channel, of course you can then do that for the right channel. What I tend to do, and this is just something more out of habit, once I've done this adjustment, I'll also go back and just verify that the DC offset is still okay. The two don't interact together, but I just feel like it's best practice just to double check that. And then once that was done, the amplifier is then left on test for about 4 hours. And that's just to ensure that the amplifier is performing faultlessly. So of course, it will be connected then to a signal generator and then also to the oscilloscope, just to ensure that across the power range that we have no distortion and that the total harmonic distortion is within specification. And we're just verifying, of course, that the different inputs work correctly, that the output power on the right and the left channel is the same, so that you don't have any sort of discrepancy between the two then. And I would always say that really working on these amplifiers is a joy. Most of the amplifiers that I get to service, I feel quite honoured when, people contact me via the YouTube channel, which was the case here, and maybe have watched a previous tutorial and said, I've had this amplifier for a number of years, would you be interested in taking on the work to restore it? Always a pleasure to do that. And then when you listen to this amplifier and the performance that it delivers, okay, there's a degree of nostalgia with it, but there's also a huge amount of pride, the fact that the owner of the amplifier is going to have many, many years of listening to music and really just enjoying the sound quality that these amplifiers can produce. So that sort of brings us to the end of this tutorial. I thank you for stopping by, and again, if you have any questions or you need any more information, by all means come back to me. And you can also email audio amplifier servicing at aol.com. So until the next time, I wish you all the very best. Cheers and bye-bye.